Good morning, chemistry students. I don't know that we went through this vocabulary, so I'm going to start with this, and then we're going to talk about how those polyatomic ions combine and the rules that go along with that. So, formation of ionic compounds. Ionic compounds we talked about are those positive and negative ions that are attracted to each other because that those opposite charges, the plus and the minus, either having more electrons than protons or more positively charged protons than they have negatively charged electrons, resulting in that overall charge. Ionic bonds themselves, of course, are those forces that hold the ions together, and it's a very strong bond. We talked about that yesterday in class with the salt crystals and kind of some of the commonalities with ionically bonded compounds. So just a couple of other vocabulary words or definitions. Chemical formula, you guys have been using chemical formulas, I'm sure, since 6th grade probably. So it's just a representation showing the number of each type of atom. So if I have NaCl, we should recognize that this is one sodium and one chloride. If I had something like MgCl2, we should recognize that that's one atom of magnesium paired with two atoms of chlorine, resulting in a net charge of 0, because we don't show any charge here. So this is an uncharged, actually a formula unit, right? So this is an uncharged compound. A formula unit is just simply one of these. We tend to use the term formula unit with ionic compounds rather than calling them molecules, even though we kind of do refer to them as molecular formulas a lot. When we talk about molecules, technically those would be covalently bonded and not ionic. All right, so as I stated, we're going to go through how those polyatomic ions combine. So looking at our handy-dandy ion sheet, I handed out in class yesterday, but we also have this posted on the hyperdoc for this chapter. So remember, the ones on the top of the sheet are monoatomic ions, meaning that they are only one type of atom. The formulas on the bottom are those polyatomic, I guess over on this side, are these polyatomic ions. We said don't use this yet. This is actually for chapter 8. So there's just some things you have to remember when suddenly we're talking about polyatomic ions, because they're groups of ions together, and it can get kind of confusing. So I'm going to go through some rules here really quickly, or some examples, and I'll explain the rules. So let's just say that we have something like lithium, which is a +1, combining with, I'm going to pick one that is commonly used really a lot. So let's say that it's combining with hydroxide. So the hydroxide ion is OH with a negative. And what that means is these collectively as a group, the O and the H combined together, have this negative charge of -1. So obviously if we have a +1 and a -1, these are going to combine in a 1-to-1 ratio. If I add these together, they combine just like that. So pretty simple when they combine in a 1-to-1 ratio. However, if we have something like calcium, which has a +2 charge, combined with hydroxide with that -1 charge. Now remember, so this is a +2, this is a -1. I'm going to need 2 of these in order to have that overall charge of 0. I'm just going to use the crossover method.
Lori Nenow to the community ed office. Lori Nenow to the community ed office, please.
Sorry for that interruption. So I can use the crossover method. So I can put a 2 down here. This is a 1. Remember, we don't write the 1, but I like to keep track of it in this part of, combining them. So I have 1 calcium, but I have 2 of these hydroxide polyatomic ions. The way this is written right now is really a problem because what it looks like is that I have 1 calcium and it looks like I have 1 oxygen and 2 hydrogen. And that's not true. That's not at all what I have. I actually have 2 of these. And I need to write this a different way so that that's very obvious. So we need to write this a different way so that our intentions here are a little bit more obvious. So this is wrong. The way we have to write this is actually this way. I have 1 calcium and I have 2 of these hydroxide. I need to put parentheses around that entire polyatomic ion and put the subscript on the outside. The other thing, so this is the correct way. I'm going to just show you really quickly another thing that I sometimes see students try to do that is also wrong. It is also wrong to say, well, I know I have, 2 of these and 2 of these, so why can't I just do this, O2, H2, because that would give me 2 of each of those. This is wrong because it doesn't indicate in any way to me that these OHs are combined as 1 polyatomic ion. So this is the correct way to put them together in parentheses with how many of those we have on the outside of those parentheses. This tells me that I have some calcium combined with some oxygen combined with some hydrogen, but it doesn't let me know that actually it's the hydroxide ion that was combining with the calcium. So this is different. So we want to make sure that we use those parentheses. So let's just do a couple more examples to make sure that we understand how this works. So let's say that I have some barium with a 2+ charge, and the carbonate, so carbonate is down in the -2 on the middle of the bottom of the sheet. So carbonate is CO3 with a 2- charge. So I can use my crossover method, and I have this Ba2CO3. I can't write the 2 like that. I need that parenthesis in there. However, do not forget, because this is a +2 and a -2, they're really only going to combine in that 1-to-1 ratio. I use the crossover method, so I have to reduce this down to simplest whole number ratio, CO3, and I don't need the 2's. I reduced it so it's 1 of each. So this is the way we would write that. Do not put parentheses where they're not needed. So for example, it is wrong for me to say, well, this is a polyatomic ion. I'm just going to always put parentheses around my polyatomic ions because then I'll never miss that step. You can only put parentheses where they're needed. You can't just put them there just because it's a polyatomic ion. So these parentheses don't do anything. They're just here. We only have 1 of these, so no parentheses can be used cases like this, okay? So the parentheses, it's only okay to use them when you need them. It's not okay to use them when you don't need them. That's a funky color. All right, so that is the correct way to write that. Let me just do, I'm just going to do a couple more examples just so that we cover all of our possibilities here. Let's say that I have potassium, which is a +1, combined with a phosphate, PO4 -3. So make sure when you look at that sheet that you recognize so this almost looks like when you look on this sheet where phosphate is, it kind of almost looks like a fraction. It's not. It's PO4 and then the charge is a -3. So it's not PO -3/4. I've had students kind of misinterpret that a little bit too. I know these are written really like they're tiny print and written, you know, really small on here, but this is PO4 with a -3 charge. So how would this combine? Well, I'm going to use my crossover method. So this is going to be a 1, this is going to be a 3. So my final formula, K3, PO4, and this charge goes away, right? This becomes the subscript over here, and then this goes away. So K3, PO4, final answer. Do not try to put any parentheses. We don't need any. We only have one of those PO4 ions. So that's the way we would write that. Okay, there's a couple of other things that I want to go through. You will notice on your polyatomic ion sheet, the only commonly occurring positive polyatomic ion right here is ammonium, which is an NH4 with a +1 charge. If this, let's say that this combines with my phosphate ion, I'm going to use my crossover method. 1 down here, 3 goes on this one. This is really the only example where we are going to see parentheses around the first ion. Almost always the first ion, which is the positive ion, always goes first when you're combining them. So the positive ion always goes first. And, sorry, I have people coming in here. And the only polyatomic positive ion is this ammonia. So only when ammonia is present do you ever need parentheses around the first ion. So NH4, I need 3 of those, and then I just need 1 of these. Okay? And again, the reason we put parentheses around this instead of saying N3H12, right, because this 3 gets multiplied by the 1N and the 3 gets multiplied by the 4 on the hydrogen, is because what it really infers and shows us what you actually have here is PO4 with 3 of these NH4s attached. So we have a phosphate with 1, 2, 3 of these ammonium ions attached. And so this tells us really the structure of that molecular structure that we have with that ionic compound. The last thing that I want to just mention is please be aware that there are some ions on here, like for example copper. There's 2 different forms of copper. There's a copper with a +1 charge, copper with a +2 charge, and there's several of them like that. So make sure you're using the right ion in those situations.